here's the Logan 210 lathe project. So this was rescued on the weekend from a pretty dodgy site. It was a bit rusty. I'll show you some photos of it prior to me getting it. So a couple of days stripping it down and cleaning up the crap. It was in pieces. So I have, how would you put it, disassembled it and then sort of reassembled it, and I wanted to get it running first before I go and do a bit of restoration. There's quite a few things that need to be done. Obviously the bed was very rusty, so that's all been wire brushed and oiled. So was the carriage and the three-jaw chuck. You can still see surface rust on the belt pulleys there. These gears have been smashed, so there is back gears which are down underneath there, so they won't engage because those gears have all been chewed off, and then same with the ball gear on the front. The spindle's in good condition, so the bearings in there are nice and quiet. The change gears, so spindle gear has been demolished and there are no reverse gears. This is all that came with it, so I haven't quite worked out what the feed is, but I've assembled it into a slow feed. This has got cross feed, automatic feed, and carriage automatic feed with reverse on both, and then also has thread cutting, all imperial and through to metric as well. So there's going to be a bit of jiggery pokery going on to get it all up and running initially. I've 3D printed some of the reverse gears, so they will literally run in there. I'll show you the broken arm in a second. Oh, they can stay on the ground. And then we've got the covers. So the covers are down there, that's to go on. And here is its 2B variable speed 3-phase motor. So it's a 3/4, or I think it might even be 3/4 plus horsepower. And I've got a variable frequency controller coming for that. So that's going to be its eventual drive motor. At the moment we just got I don't know whether it's probably original. No, it's not. Wouldn't be the original. A single phase electric motor. This lathe is from, loosen that. So we can see the numbers there. 1944. So she's fairly old. So I got it running this afternoon, so I'll fire it up. So here we are running. So there are 3 different belt drive positions. I can't quite do that, so I will just drop the lid and then start it. So there we go. So these are the change gears for thread cutting and also for feeding the lead screw. Loosen this off. there is the table feed, and there is the cross feed. So they can be run together or independently. I'll probably have to go with a quick change tool post. It's a pretty good bed. I think the length of it might be 700 between centres. It's got a number 3 Morse taper in the spindle, number 2 on the tailstock. The tailstock's had a bit of a break and has been re-welded, but that's not going to deter from its function. But you know, the rest of it, I mean, the bed is fairly good. There's no major pitting or excessive wear. I think it's a hardened, I'll have to have a bit of a nosy, but yeah, so going to be quite handy for getting some components done. Now this is another interesting thing here. This O-ring is an ingenious way of the previous owner to actually drive the belt. I'll stop it and then show you what's going on. I'll insert a little image in here, what specifically showing what should be there, but this should be the spindle gear driving the 2 reverse gears. So this lever will change from that, driven off that gear or driven off this gear, which gives you your forward or your reverse off the spindle, and then you can adjust or change out these change gears. I will 3D print them. This is all that it came with, but I have luckily found all of the files for printing the gears, so that's going to be relatively easy. And because it's only driving a lead screw, there's not a lot of load, so the plastic gears actually do reasonably well. In fact, modern lathes go with plastic gears on those on the change gears.
Discover what's behind the curtain with Redgrave Home Fabrics.
We specialise in curtains and blinds because they are our passion. They are the products we love and protect us.
Here's a bit of fun. Cutting 65mm solid bar with a reciprocating saw. It's doing quite well, apart from the jiggly of the only using one arm. This is going to be used for a spacer on the quick release tool post for the Logan Lathe. There you go, 65mm bar cut through with a reciprocating saw, the mighty Yazito, and that was literally one 2 amp hour battery, and then the final finish with the other battery, but it literally was seconds. It just slowed down, so I thought I'd better chuck it in charge. But and it's a fairly straight cut. In fact, I'll measure it and see how well we go, considering I did it all one-handed. So there is a bit of a wobble. I was trying to cut it off at 15. I got 15.6, 15.9 and 17.2. So not that good with one hand. I'll have to do better next time. The reason for this spacer is that, see how high the quick change tool holder is? I need to lift it up off the compound. So we're going to do a 12mm spacer, and then it should be able to sit in the middle. So here's the spacer on the bottom of the quick change tool post. Needed to add 15mm so that we could bring the tools up to height. For some reason the recommended tool post is too low. Maybe I need to go up a size, but just adding a 15mm spacer to the bottom on the compound slider made a huge difference. I'm just having a little bit of a play with some cemented carbide tools. Reasonably good finish in boring, and then just a little bit of machining on the edge. I machined this, so that's kind of come up nicely. I did try change gears, so when I machined this, the feed was a little bit coarse because we've got limited change gears. I have put a plastic one in there to slow down the feed. It seems to be running perfectly fine. I actually need a spacer because it's popping out, so I will machine a spacer, and or I can even print a spacer, one or the other, and then take it from there. Actually, it's kind of interesting that it's sticking out so far. That's weird. Okay, I'll make the spacer up. I'm running the original single phase motor, so fairly old, and running onto another pulley. I've got the cover to go on, but we'll have a play with the controller and the 3-phase motor, and then see what we can come up with. So that's probably going to be the next project. The lathe is pretty rigid, although it's not bolted down, so I'm going to have to bolt that down. It's also way too low, so I need to lift it up probably about maybe 150mm. In fact, maybe I'll just bring it up to the same height as that bench. I just feel like I'm leaning over and getting a little bit of a crick in the back, so we'll give that a whirl. Lot straighter cut this time. Put it in the chuck, put the live center up against the end, and then just marked it, just basically scored it with a tip and a marker, and pretty accurate. Just ran it around with the sawzall, not while the lathe's running, just manually. I should have filmed it. This is going to be the pulley for the variable speed motor, which is down there, which actually got running this afternoon. So I'll make the V pulley, and then we'll be able to change over that during the week. So here's the pulley for the 3-phase motor. So that's the first one. Basically it's just steel made from the stock I bought earlier. The limitations with the ability to not use the feeds very well, and just literally every belt slips, so the little old motor just doesn't have enough poke, so it's been fairly much a manual manufacture. So we'll make a decent one for it once we get it all installed, and then once it's driving itself we'll get a load of torque. So here we go. I'll let it cool down and then take the last cut when it first size and see how we go. Please add your thoughts and comments, like and subscribe. Let's grow this channel.